Gemini.
Hey everybody, welcome to Track B. Again, I'm Sonia, and I'm really excited. We have Jeff Hoffer here today to give our next talk. I'm really excited about it. When I was chatting, well, we asked Jeff to share with us something that people might not know about him, and he mentioned that he is a really loud clapper. So when I heard this, I was like, I also am a really loud clapper. So obviously we have to have a clap off, right? Are you ready? We both practiced a little bit yesterday, so you ready? Do you want to go first?
Why do I have to go first?
I mean, I was just going to give you the honor. You're our guest here.
Ladies first.
All right, okay. All right. It's about palm depth and moisture, okay? So there's an
She's thought about this a lot more than I have.
I really have, so.
It's pretty loud.
All right.
All right. Maybe I should have gone first.
I'm stressing now. You're going to beat me.
Mine's more like an audience applause clap, so.
Thank you for humoring me with that. Wow. Those are some exceptional claps. I think we have some competition in the audience.
I know. There's definitely some good loud clappers out there.
Well, thank you all. And without further ado, we got Jeff Hoffer.
Thank you. Thanks everybody for joining. The lights are really bright, so if I'm looking down the whole time, that's pretty much why. Also, this is the first time giving this talk, so I hope that there aren't moments that I just pause completely and lose my train of thought. So bear with me. So the talk is We're the Same, You and Me, a new way to align programming paradigms across client and serverless. So this talk and the concepts and ideas in it are born out of years of experience working in startups and working on legacy systems, and too often working in a startup on a legacy system that is legacy way too quickly. So I imagine some of you can relate to that, and I hope there's some inspiration there for all of us. When I talk about a new way of programming to align these paradigms, and more generally execution environments, I am referring to something I call the Tau model, or Tau programming paradigm. And it has three specific parts. It provides a message format, three various ways to handle messages, and a signal network. Is the audio okay? The Tau model derives its name from an acronym for the message format to make it easy to remember, especially the ordering of the parts in every message. We're used to messaging that specifies the action or operation but the Tau message differs from traditional messaging in a few ways. Specifically, it provides 3 degrees of freedom, which will make a lot more sense when you see it using in wildcard handlers. Also, we embed the subject of the message within the message itself, whereas most messaging systems, or most messaging we're used to, the subject is either the source or the destination of the message. And the inclusion of a third dimension, the orientation, allowing us to view the description and context of our application from all angles, not just a two-dimensional view. So the Tau model also provides 3 distinct ways in which we can attach handlers to our signal network. Inline handlers are those that we're most used to in evented systems. They happen in an ordered sequence, and these are our ordered desired effects. But it also provides 2 other mechanisms. One is an async attachment, so that we can explicitly create out-of-band side effects, as well as an intercept handler that allows us to halt operation and add guards to our execution flow. In the Tau model, our trigrams describe discrete application in the Tau model, our trigrams describe discrete application contexts. We use a signal network that connects those parts that are generating these application contexts to our handler code, which is observing and reacting to these application contexts. Our signal network also provides the ability to chain these messages in a way simply by returning a new application context to the signal network from your handler. In this way, our signal network is implemented the same and has the same interface, no matter whether you're executing it on the client or a server or a serverless. The Tau model is currently implemented in JavaScript under the name of tau.js. There are 3 packages on NPM published. The core implements the Tau model itself and provides the public API. You can include it in any package you want and start using it right away. React package provides an adapter to turn components into Tau handlers, as well as a reactor component that will react to the signal network and render the component that you'd like. The socket.io package implements the signal network so that it spans client and server. So let's take a look at some code. Y'all can see that okay? Should I zoom? Let me move all of these. Hides these. How's that? A little more? A little more? Better 1, better 2. Better 1, better 2. I can't see an optometrist and not crack up when I'm going through that. So simply, Tau.js core, we go ahead and import the Tau, which is our signal network implementation here. And then there's another piece that we can import is the appctx. So that allows us to generate application context that we can return from a handler and tell the signal network to chain down to this next message or event or application context. In addition, for our server, we are importing our wire Tau.js to socket.io, and that's all we need from there. So once our server is set up, so this is a Koa server attaching a socket.io. For each socket that comes in, we will wire it up and use our onConnect method init client Tau. So on the server side, we actually end up with 2 signal networks, one that we can use to handle all application contexts and ones that are specific to our client. So whenever a connection occurs, this one is called back, and then we attach our handlers to it on the client side specifically. So our init client Tau, we get the new client Tau, and it has an ID. I'll ignore that for now. So we set up some inline handlers that we need to occur on our server. Our example application, it's super bare bones, just to be an example so that you get the gist of what's happening and I'm not dazzling you with my terrible CSS. So the concept behind it is it's an application for creating your own spaces of your own vocabulary, words, and so it's going to have spaces and phrases within those spaces. So for now, we're just using the space as an example. So in this, we have a term, space, an action of find, and our orientation is the portal that most users will see. So we have an async operation where we're going to take what we're being asked to find. Find can be undefined, or it could have a specific ID, which tells our handler to react in different ways. It will use our spaces to go find the spaces if there's no specific ID, so it'll go get all of the spaces, or it'll find one and return it directly. If we encounter any errors, we set up an action. We chain on towards a space of a fail, and we send that message on so that the client can react. So this is very basic stuff. Go ahead and lose all that. Inside of our web application, so up in here, when the client loads, we're going to import this tau init, which will give us an initial application context to set the wheels in motion within our signal network that somebody has entered the application. That file looks like this. So this sets up our socket IO connection, and we don't need that. And then sets up a series of handlers that will occur as the application is going. So we have an app enter portal, app view the portal, session find portal, session create portal. So we add an inline handler for when somebody enters the app, and we return a view application context that we want to happen. When the app view portal happens, we want to go find spaces, and we don't specify any one space by giving it an ID, so it returns everything. These are old. So as we react to the find, that's how our find method, or our find kicks off what happens on the server. So this is going to respond with a list. So let me fire these up and pray that it works. Should. It's pretty simple. Of course not. It's my fault for commenting out things I thought I didn't need. 219. Nah. Okay. Koa, you're back in. Actually, I'm just going to put all this REST stuff back in. So when I first built it, I was testing it out with not using socket IO, but interacting with a REST API, which works just fine. There we go. Now let's welcome. Okay. Something I didn't. What's that? Yeah, that's probably the best idea. Get reset head. Force push. Let's see. There we go. Thank you. So what we see here is, and I will just clear the console, refresh. A series of events occur as we go through this process of bootstrapping and rendering our app. So we initially set off the app enter portal, which then kicks off of trying to find a session that exists. And this is done, we have an async handler for that, so we don't block the app view from happening. And we enter the session when it's found. We go find spaces so that we can list them and show the list view. So showing how it integrates with React. In our app, we simply are grabbing space from our components and then rendering it here. So in our index here, what we're doing is creating a space container, and we have two different reactor components that are exported from our tau.js React package, along with the adapter. The adapter we use as a way of adapting, we wrap our tau signal network and then set a default context so that all the component handlers we set all use the term and orient for space and portal, so we don't have to keep repeating those. And then if the action comes in as list, we want to show the list view, the list component. If it's a view, we want to have the view component. And if it's a new or edit action, we want to show the form component. Now, if you look here, each of these, the view components are just basic React components. The space view is a functional component. It has nothing to do with the tau except for using the signal network to actually set the context if somebody clicks a button. Same with the list. It's nested components. And then our form component is, extends component, has an editable state within it, but it's not doing anything with the tau other than being a handler for an application context. And prettier is complaining. So if I new save it. We now have that space. We can go back to the list. Can edit. it's there. So all of the code is built using the same paradigm for the client side as well as the server side. And jump back to our presentation. So all of my friends and colleagues that I've shown this to say, hey, that's really cool. But they always ask me the same question. Why do we want this? As a plucky recent college grad with my first corporate job and my first corporate boss, I was armed with design patterns as a solution to all the coding and architectural problems. So when I noticed that the team wasn't talking about design patterns in any way, and largely nobody seemed to have heard of them, I went to my boss and I said, hey, I'd like to give a presentation on design patterns. I think it would really help the team. I think it would really help us, the applications we're building. And he responded with, all software approaches a state of entropy over time, so I don't see any point in design patterns. Thanks. True story. I'm pretty sure he was talking about the second definition here, since we were talking about how to build project management software and customer service software. And as much as I didn't like it, he was right. All software systems do end up heading towards entropy and states of disorder. So we have three major causes of entropy in our applications, most of which are born out of this need to build and prove our application and what we want to create without incurring the overhead of building it right. Even in cases where we set off to build it right, because we have budget and time, managing these three factors through traditional architectural and design patterns attempt to control the entropy. Microservices is another evolution in this direction of controlling entropy in systems, but they come with additional overhead, requiring additional tooling and support and infrastructure in order to embrace them. So what if we embrace the entropy? We know it's coming. What would it look like if we could just embrace the entropy that's coming in our system? We would have to plan to manage these three aspects of entropy: the tight coupling, scaling across processes, and extending our application beyond its original concept. So in the seminal work that started the design patterns movement, the Gang of Four put a quote in there that was designed to make us better developers. It's programmed to an interface and not an implementation. Interesting in that, in an interview in 2005, Eric Gamma, one of the authors of the Design Patterns book, spoke about interfaces defining the vocabulary of the collaboration of a system, and how understanding these interfaces, you could get an understanding of the underlying problem of a system. So if we want to embrace entropy, by avoiding the tight coupling and elaborating on Eric's words, we need a mechanism for comprehensive interfaces. Comprehensive has two definitions, and we want to use both of them. We want our interfaces to completely define our system, while we also want them to be easily understood. We end up spending time and effort abstracting the fact that we are using a REST API as a backend from our client app, creating overhead and abstraction for what? We never end up swapping out the REST API for something different. That takes too much time. Most often, these abstractions and interfaces we create deal with the how of our system, to the point I've seen applications that have a React client app with 3 different mapping layers from Redux to our component. And this ends up just creating a lot of overhead for the next developer coming along that has to add something to it. This is where domain-driven design can help us define the what of our system and focus our interface attention where changes towards disorder occur most, and that is in the what. So our tau message is the interface. We can use these trigrams of term, action, and orient to create an interface description that anyone else can easily comprehend, as well as create a handler for it. And we generally think of terms as entities in our domain from domain-driven design, but it can also represent a relationship or other domain term, non-domain term that is useful for our applications. By being distinct three strings to represent a possible application context, the tau trigrams are not bounded to anything other than representing what your app is doing. Now, when we're generating an event in our system, all it needs to do is provide the specific application context to the event. This includes the tau trigram and the attached data that goes along with it. And our handlers are called when the trigram matches what they've subscribed to, so they just wait for the outcome and react to it. We have now resolved our tight coupling problem with a simple mechanism for defining interfaces that abstract the what of our application. And we didn't choose a message-driven paradigm by accident. The next problem to tackle entropy in our system is to deal with the scale problem. This problem usually shows up in algorithms that are written that aren't made to deal with scale, and they're deeply embedded and they calcify to the point where once it's time to scale, we have to pull back and find and rip these things out deep within our application architecture. So to embrace this entropic cause, we need to decouple scalability from our system that we use to build the application itself. And we do this by using an evented, message-oriented architecture baked into the tau through the signal network. So this is a quote from Wikipedia. I remember it slightly differently from my object-oriented class in the reading in college. And I was struck by this concept that when an object calls a method on another object, it is passing a message to that object. And this original definition came from Smalltalk, where it literally was passing a message in the implementation. But the metaphor and the abstraction is the same. So in essence, we're already building message-oriented applications. We just don't seem to agree on the message format and the messaging paradigm itself. So this is not a new pattern, but one which we have separated client from backend when we build our evented and message-based systems. Evented implementations originated from user interface designs long ago with the observer pattern, which the tau signal network uses to its advantage. Message bus systems are prevalent in high-scale backends and using message buses. And the problem with that, generally, that I've come across is that whenever you decide to go with a message-oriented backend, you then have to decide what is the format for our messages every time. By leveraging the tau trigram message, we've got the format figured out. It's dynamic enough that we can allow it to work for any context in any situation. Now, the Flux architecture introduced a lot of people to the concept of unidirectional data flow. And it's something that existed in back-end data processing for some time. And it's now a welcome addition in client-side development. The tau embraces unidirectional data flow in that handlers when you set the context on the signal network, there is no return coming back to the caller. So there's nothing to sit there and wait for. So you're setting a context and letting it propagate through your system. This allows us to have a single paradigm across all the execution environments. So now that we found a way to decouple scalability from our application building system across all environments to resolve the scale problem, we can embrace the entropy to come. We need to have a way to evolve our application beyond its original intent. Again, microservices have come to our aid in this department, but once again on the side of controlling entropy. Microservices as an architectural choice move us back in the direction towards Corba and DCOM of distributed components, but in this case, we're running them in their own processes, they have ownership of their own data, and they leverage web standards for their network and interface definitions. But what we're really looking for is not just a componentized development, but a method for adding or injecting extensions to our application in our system that we didn't think of while we were building it. This is to embrace entropy. Many frameworks actually provide extension points within them, but all of these extension points are tied to the given framework, and there's no standardization across frameworks. There's no standardization of extension mechanisms from client and server. So there are, you guessed it, 3 ways the Tau implements dynamic extension points. If anybody's counting the number of times I say 3. The first is the 3 different types of message handlers: the intercept, async, and inline. If you notice, I flipped the order from when I introduced them at the beginning, and that is because this is in the priority order in which they are executed by the signal network. And this gives us a way to deterministically configure the order in which our handlers will be called, even though they're added to the system dynamically. The second way is through the second way for dynamic extension is through wildcard handlers. So we can add handlers that can handle, in this case, anytime anything is added on the admin. Or we could have a wildcard for any of them, any application context that comes through, any message. And the third way is through this chaining mechanism. As we build our application, we're not going to think of everything ahead of time, and that's by design. Entropy occurs when our product managers come to us and say, well, I need it to do this now. So we can now inject a new event in our chain, a new message in our chain, and then subscribe to that and add a new handler, and then thus not touching anything between. So aspect-oriented programming is a paradigm that allows a separation of application logic from what's called application-wide or cross-cutting concerns, like security and logging. Most AOP implementations provide point-cut systems that perform cross-compilation to inject code, but they're generally focused on binaries and single execution, single executables. By broadcasting our Tau messages on the signal network, we can have our AOP cross-cutting concerns handled system-wide, and we get this for free. So now that we've resolved to embrace the entropy to come of our application by considering all 3 major causes of entropy, let's see some examples of leveraging Tau.js to add to our example app. So now that we've gone through the process of we want to be able to now add caching to our server. So we're not going to change anything on the client side. It's still responding to these events. Let's see. There she is. So what I now want to do is so we had our inline handler for space find. What I'm going to do is add an intercept handler for space find that's going to test to see if we're looking for a specific space, and if not, we return, and then the inline handler is going to be called. It's then going to, if we make it past there, I'm going to go to Redis and try to get that item. If I didn't find it, we missed on the cache, log it, and return. It'll call the inline handler. If we did, we're going to reset the context to enter portal, and that will prevent any downstream application context from occurring. So that is a cache check. Now, how do we implement storing? So because we're already in our save space handler, we were returning the application context as space stored. We're also broadcasting that on the server-wide signal network. We'll simply add an async handler globally to anything that's stored and grab it and stick it in the cache. Now this was already working because I undid all the commenting, but I'll go ahead and show you how that's working. So if we have in Redis, we've got our JSConf. We go ahead and hit that. And then we see in our logging, cache hit. That's what got returned. Back to the list. This one, Dwiddle B, is not in our cache. We'll go into that. We'll see cache miss. And by the way, all the logging is simply adding a wildcard handler as an intercept that never returns anything. So we never intercept, we never block, we just see it coming through. And that happens here, as well as in our client. So this one was a cache miss, but if we go ahead and edit it, we'll now see that gets stored in our cache. And the next time we go back to the list, we'll have a cache hit. I think I'm close to out of time. So with all this, we get a lot of additional benefits. We're building on an architecture designed to evolve by embracing the entropy inherent in our systems. It's completely composable and decoupled from day zero. you have the ability to use the best tool for the job. So because everything is just a handler, you can use whatever you want. We get to build reactive applications that come with the common semantics across all of the execution stacks. We get, like I said, aspect-oriented programming system-wide for free. We're getting a stream of events with rich metadata that we can then use for reporting and tracking. And by using this tau message concept, these trigrams, it provides a ubiquitous language, like we talk about from domain-driven design, that we get to use with our non-technical and our product members of our team. And then this same language ends up translating directly into the code. More things to come, tools, meta description files, decorators, testing and debugging tools. At the moment, it's a little verbose, but by creating meta description files, we can wire this stuff up on the side. Router for manipulating and reacting to URL paths. Middleware and adapters for different front-end components. Wrappers for the different FAS providers. And a tau mesh that would be able to conjoin signal networks to make that aspect seamless, as well as implementations beyond JavaScript, so you can have handlers implemented in any language that basically can support this simple paradigm. What do I need from y'all? Please try it out. This is brand new. This is from a lot of years of me thinking about this problem. And especially I want you to tell me what's wrong with it. I do believe in this paradigm as a simplified way of building applications and using the strengths of our tools rather than fighting against them as we're dealing with various entropy. There is no sponsor. It's just me. So if anybody wants to contribute, it's all open source. Feel free to share your feedback, and please come talk to me more if you're interested in working on a project that makes it easier to build applications quickly, where you're not having to worry about the underlying architecture, which can evolve with you. Thank you very much. I want to thank everybody at JSConf. The hospitality here has been amazing. And thank you all for attending.